All right, so I lied, and I said the fourth one is going to be very technical, but no, the fifth one is going to be very technical, and you can see by the fact that I'm going to be employing a ruler to be very, very specific. So there's three steps to derive the labor supply curve. The first one is to construct a indifference curve. Now you may have remembered these from I think it's 202 and 302 micro, where and we look at it both in the consumer and the supply side. But in this one, we're going to be looking at it from a, what would you call it, a labor supply, or I'm sorry, a labor context. So first thing we're going to do when we're mapping it, or when we're showing an indifference curve, is draw an indifference map. So again, I'm going to draw a little curve here to show you exactly what I'm talking about. Oop. So down here, we're talking about two different variables on the horizontal x-axis. So this is, again, these are going to be in units of hours worked. So leisure and labor. And the units are derived both ways. And by that I mean you can have a 0 here. We'll say, we'll go in 12 hours, or I'm sorry, 24 hours, just to make it realistic, because there's only 24 hours in a day, so we're doing it by days. So 12 and 24. So 0 hours of leisure, meaning you work 24 hours a day. 12 hours of leisure, or 12 hours of labor, meaning you have 12 hours of leisure. And then 24 hours, my mistake, 0 hours of labor, meaning that you consume 24 hours of leisure and you earn 0 income. All right, so now that we've got that figured out, now we're going to label the other portion of the graph, which is income. And that is different from the wage rate, and it'll become obvious why as we move through this. So what we're going to do now is draw three indifference curves, and I'll explain the shape and convexity in a moment. So we've got I1, I2, I3. So these are our three indifference curves, and there's a couple properties that comes with them, and they are that they are negatively sloped. So they're downward sloping, obviously, kind of like a demand curve. And that really just signifies that there is a trade-off between income and leisure. Or you could say leisure and labor. I think that'll actually make more sense. And again, forgive spelling mistakes. So yes, it's negatively sloped, meaning that if you consume 1 hour of leisure, that means you're consuming 1 less hour of labor, and vice versa. That's really all that means with the negatively sloped. It's also, what would be that? Is it convex to the origin? Yeah, because a cave would make a cave. So this is convex to the origin. Oh, I can do better than that. Excuse me. So convex to the origin, meaning that it kind of like goes this direction instead of this direction. And that has to do with the marginal rate of substitution. I'm not going to write it all out because that's a big one. Marginal rate of substitution, so MRS. And all that means is that it changes more at the extremes. So again, delta means change at extremes. So I'm going to show you what that means exactly. So let's say we're going to look at three different points. Point A, point B, point C. So we've got three different points. So first, let's look at point B. I'm going to draw these down here. Might not be able to see, just give me a moment. So here, it's kind of in between here. I'll say maybe 10 hours of leisure, and that means you've got, what, 14? Is that right? 14 hours of labor. So you're working 14 hours a day, consuming 10 hours of leisure. for let's say $100. You got $100. You're doing that. So now let's say you move to we'll say B prime. B prime up here. So now you are consuming, we'll say, 8 hours of leisure. Actually, we'll say it's a little bit more profound than that. Say 5 hours, well, let's say 4 hours of leisure, 20 hours of labor. So you're working a lot now. And you go up here. So now you're, let's say you're earning, I don't know, 150. Say that. So that's the change there. So you were working 10, or I'm sorry, you were working 14, now you're working 20. It's a change of 6 hours. So that's a 6 hour change. I'm sorry, other way around. 6 hour change, and you gained $150. Or I'm sorry, $50. So you can see there's the rise over run. So that would be 50 over 6. I can't do the math in my head off my head, but if you do that, that is essentially going to be your marginal rate of substitution. But if you do something like, let's say, C to C prime, I'll put C prime over. I'll put all the way over here. Hopefully you can see that. Let me check. Yeah, you can see that. I'll move it up a little bit. So C to C prime. It's a small move. So I don't really need the ruler for this small. But for this long, I will. You can do the math in your head. Just go ahead and do that for how much the MRS is going to be from B to B prime. And, let me just do it right now because the math will make sense. Hopefully you can see this. So, like I said, it's rise over run. It's just the slope of the indifference curve. That's what the MRS is. So we've got 50, we've got 6. So MRS is equal to 8.33. So it's 8.33. So that's the MRS for point B to B prime. And then from C to C prime, or C prime to C, whichever way you want to move, let's say you're working here, and again, this isn't exactly super technical because I don't have it scaled correctly, but if I did, we could do it and there wouldn't be much change. But, oh yeah, I didn't even do this side. Give me one moment. If I'm blocking anything. So you can see right here, let's say this is, I don't know, 22 hours of leisure. So that means you have 4 hours of labor. I'm sorry, 2 hours of labor, my mistake. And then down here, we'll say it's 20. So it's a difference of 2. So 2 hours and maybe a marginal difference of a couple dollars over here. So let's say this is like 75 and this is like 80. So that's a small, like a 2 hour difference, and you get a $5 increment. But here you get a $50 increment for 6. So you can see that at the extremes, the MRS is going to be much, much larger than at like the middle ground, and that's just represented by the convexivity of the whatever it's called, the indifference curve. So yeah, like I said, it's technical, lots of fun. Oh, another thing to note about indifference curves is they can't cross. Like you can't have an indifference curve like this. Let's say this is 4. You can't have that. Because then there would be 2 points of optimization. Also, that means that along every point, like I should have made a note in the beginning, A, B, and C are all preferable, or I should say they are all equally preferable between each other. So A, B prime, B, C, C prime, they all yield the same level of utility for this individual. Obviously, indifference curve 2 yields, or all points on indifference curve 2 yield more utility than all points on on indifference curve 1, and same for 3. However, that is not the case between 3 and 4 because there is a point at which they yield the same utility, but then there are several points at which they yield differing points of utility. So you can't really have crossing indifference curves at any point, so none of that. And like I said, the reason for that is just because there would be different points of optimal utility levels on the same, or on 2 different curves, which just violates a lot of assumptions. Okay, so now this is the other one. We're going to go over tastes and preferences and how they are utilized or exemplified in indifference curves. Hopefully I can do this one pretty quick. So there's two types of individuals we're thinking of, or I should say there are two archetypes of individuals, and then people tend to either be more towards one or the other. That's kind of how it flows. So again, this is about tastes and preferences. I'm going to draw two graphs. Oh wow, that was terrible. But go ahead and ignore that. We're going to draw two graphs just to exemplify what I was talking about. Try to make them somewhat equal. Somewhat. So that's 3, 5.5. All right, so those are roughly equal. So again, we're doing tastes and preferences. We have person. We'll have a person over here, which is we call leisure loving. Meaning that they love to consume more leisure than they do labor. And then over here is labor loving. And you can come up with any sort of like tool to identify the two. I think Pietrykowski used worker bee and slacker bee or something like that, but they're all the same. So leisure loving, there are two different ways that we can draw the indifference curves. And again, these are just archetypes. Real individuals fall in between some of these. So the first one would be indifference curves that look something like this. Very, the slope is very, very high. So the MRS is high relative to someone like the labor loving, where their indifference curves are more flat. And you can take a second if you would like to pause the video and think about why these two curves might exemplify these two different archetypes while I write these out. Okay, so again, these are trade-offs still. So labor is, or leisure is up here, labor is up here, or down there, and then same way as here. If you just try to think of it like that, where, like I said, in the other one, you have leisure on one end of the axis and then labor on the other end, and they're just trade-offs. So if you have 12 hours of leisure, you have 12 hours of labor. So now I'm going to exemplify why this person is leisure-loving. So let's take a point on indifference curve 1. Let's take it right here. Call that point A for now. And then we'll take a point up here, point B. Again, point A and B they're indifferent to them. That's why they're called indifference curves. So they all yield the same level of utility. So let's take some technical details here. So let's say they are consuming, what would that be, 2 hours, or I'm sorry, that would be leisure. So let's say they're consuming 12 would be around here. Is that 24 over there? No, that'd be 0. So let's say 8 hours of leisure, and they are, and then they are yielding, we'll say they're very poor. So $20, that's all they get for 8 hours of, or I'm sorry, that would be actually a lot because they'd be working, what is that, 16 hours of work, something like that. That's a lot of work. Regardless, so if they move from point A to point B, B's going to move down here. Now they are consuming a little less leisure. We'll say now this is down to 4. However, they are going to have a large jump when it comes to their income. Let's say that's 120. So think of this jump. This is a jump up to $100. So $100 change right there. This is only a 4-hour change. So in order to give up 4 hours of leisure, the leisure lover is going to need $100 of extra income. So that means that they obviously value leisure much more than they value the work. So they want more time to do that. So that's kind of like the shape of the indifference curve for a leisure lover. But for a labor lover, we can kind of see the same thing where, let's do a big change here, big change here, call this A, call this B. Again, just making sure we're very technical with our details here. Maybe not consistent because scaling is very difficult. You might be able to see the difference in the change here, where labor, let's say leisure, they had, we'll say 18 hours. They had a lot of leisure time. And then they went down to, say, no, we'll say 10 hours of leisure. But at point A, when he was consuming 18 hours of leisure, he was getting, well, let's be consistent, it's kind of like close to 120. And then we'll say at point B, he's only earning 140. So that's a $20 change. But this is an 8-hour change. Oh, sorry, let me do this so it's not confusing. Totally looks like a Z, not an arrow. So this is an 8-hour change. So you can see that a labor lover is willing to give up a lot of extra leisure time in order to gain a lot more, or not as much income. So hopefully you can understand the difference between these two, and hopefully you're able to skip out here or skip through these pretty quickly. And another way to think about this is that the steeper, or I should say the higher the slope or the steeper the curve is, the more work averse the person is. So I'll write that out. So the steeper the indifference curve, the more work averse, and then it works the opposite way. Is like the flatter or the smaller the slope, the less work averse, or I should say, you could say more work loving instead of work averse, because that's just a way that we can terminologically define these two. So yeah, that would be the first portion is the indifference curve. The next one, next lecture, will show you how they implement the budget constraint. When we talked about constraints earlier, this is how we implement it.